My name is Rick Margolin, and thank you for joining us for today's webinar on how to leverage Genscape's proprietary activities monitoring Texas intrastate natural gas storage. The webinar today is going to be conducted by our Managing Director for Natural Gas, John Ecker, and our Proprietary Natural Gas Analyst, Hannah Burke. Just very quickly before we get started, I want to note that there is a box on your screen in which you can put in questions. At the end of the webinar, we'll go ahead and do our best to answer as many questions as possible. We will answer any unanswered questions later in the week following. We will also make the slides and webinar recording available following the webcast. So with that, I'd like to hand it over to John Ecker.
Thank you, Rick. As many of you may know, Genscape has been working for several years trying to demask what's been happening in the intrastate storage realm for natural gas. We've had some interesting starts along the way, but at this point we've got some technologies that are actually working very well and providing significant improvements in the models that we've been running internally. And we want to share some of those results with you guys and run through some of the methodologies that we've been using and provide some of that information to you. So along this line, I'd like to introduce Hannah. Hannah, would you like to cover some of the methodologies that we're using and some of the ways that we're observing proprietary information storage?
Sure. So the first part of this that we decided to tackle was the power monitoring at storage facilities that have electric compressors. We've been using this technology of EMF monitoring for years. This is where our power data comes from. And so we've put these on a number of facilities using electric compressors, and the data correlate very well to injections. This graph is showing our observed megawatt values at North Lansing since the start of this year, or last year, sorry. And through the winter, you can see the withdrawal period. Observed megawatts are basically nothing. At the start of injection season, things ramp up through injection season and then back down through withdrawals. What this does not cover are facilities that use gas-fired compressors. To manage this, we've installed infrared monitors, like shown here at Markham, that take a time series of infrared images of the compressor stacks. The video on the right here is showing the infrared images that we have come in daily. And you can see as things light up, each of these compressor stacks marked on the right, or on the left, sorry, get bright and then pull back down as things turn off. This is a very good indicator of the operating status of each compressor and is a very clear signal of injection. The graph that you're about to see is going to demonstrate just how closely these time series data of megawatts and on-off status of gas-fired compressors correlate with injections. During injection periods, there's a very tight fit, and then we don't really get much transparency through this on withdrawal periods. To manage that, we've installed infrared cameras focused on the dehydrators. Here you're seeing an example of the 3 West BAML dehydrators. In the image on the left, all 3 dehydrators are on. They look bright. In the image on the right, only one is on, the one on the far left.
These dehydrators, what were some of the challenges that you were seeing?
With these dehyds, we were worried at first that we may not be able to get clear signals when the air was particularly hot or humid down in Texas, but we've seen that we get clear signals no matter what. We're able to determine whether these things are on or off. We've also found in our last year of having multiple facilities monitored that not all facilities behave the same. Some facilities run their dehydrators when they're both injecting and withdrawing. To manage that, we decided to monitor the inlet separator which thankfully comes with each bank of dehydrators, and is a very good indicator of whether the facility is injecting or withdrawing. The inlet separator is only used during withdrawals.
Sometimes run dehydrats while they're injecting, but they will always see activity on the separator when they're withdrawing.
Yeah.
So as we observe this information, we were trying to figure out where the best areas would be for us to implement our monitoring. As far as these targeted facilities go, we did decide that we'd be managing them more for Texas than in other locations. And so let's go ahead and take a look at what our coverage looks like in the Texas market.
So with our facility selection, we decided to break these out into facility types, looking specifically at salt domes and conventional fields. And to narrow down our target sample, we looked first to facilities with the highest working gas capacity and best correlation to overall facility activity in Texas, or facility type activity in Texas. So in these charts, you can see the fields that we labeled as must and high, the ones labeled with a little red box. Those are the ones that we identified as being the most important and crucial to our correlations. As you can also see, we've got all of these. We have at least partial coverage on every facility we targeted as a must. Here are some of our preliminary or target correlations with the Texas conventional fields. The 4 facilities we targeted in Texas as conventional make up about 75% of overall conventional field storage in Texas. The graph on the right shows total Texas Railroad inventory for this field type on the x-axis, and total sample inventory reported by the Texas Railroad Commission on the y-axis. The correlation of these sample facilities, or targeted sample facilities, to overall Texas activity in that field type is about 0.98. This is a very good correlation, and what we hope to achieve if we get perfect correlations with our observations at each facility. The same is true for the salt zones. Here we're seeing total Texas Railroad inventory for salt domes on the x-axis again, and our targeted sample on the y. And this is an even tighter fit as we've selected one extra facility in salt domes because of the unpredictable nature of their injection and withdrawal behavior. So combining these two to look at overall storage in Texas yields a very good correlation of 0.9899. And this is what we hope to achieve predicting all of Texas. So here's where we currently are with our target facilities. On the conventional side, we have North Lansing and Bammel with complete coverage and daily estimate, as well as West Clear Lake, for which we have injections only, but hope to have withdrawals within the next couple weeks. For salt domes, we have Markham, Bowling, and Dayton North with complete coverage, and injections at Spindletop and withdrawals at Spindletop should be following West Clear Lake.
So as far as the facility modeling and the results go, let's talk in some level of detail about what the correlations look like between these facilities on a monitored data. As we look at these results, we can see that using our infrared cameras at the Markham facility, we're able to arrive at a total utilization percentage on a daily basis by gas tank. So that's what we're showing in the chart there is the daily percentage. These information are derived by looking at infrared cameras at the target facilities. We observe anywhere between 24 and 96 images at these facilities for each day. Our analysts evaluate those images, as you saw in the infrared pictures, for determining where the events are happening and what time these events are happening, and then we categorize that into a total percentage of activity for the gas tank. This process has been useful in that it provides us the ability to really observe what's happening and reflect these observations prior to changing these estimates into a MCF value. So here's a look at what we're doing at North Lansing to cover both the injection and withdrawal side and how these observations manifest. So on the left-hand side, we've got the megawatt observations. On the right-hand side, we have the percent of total capability activity that is active in the dehydrator side. And then we categorize those again into injections withdraw. We calculate that into a monthly correlation between the observations and the Railroad Commission information, and then we scale that information back into a daily estimate. So here we're looking at how that information manifests at an individual facility. So this is the BAML inventory observation. And this is a complicated slide, so I'm going to spend a little time describing what it is we're doing here. In the background, we've got the bars, which represent the monthly reported inventory at BAML from the Railroad Commission. The orange line, the dotted orange line, is our observations and what they would imply for a daily change accumulated over the entire life of these observations. So we have a little over a year that we're looking at here. And the daily change just from what we're seeing at these facilities converted to MCF. And then the blue line is adjusting what our observations are showing for what is ultimately reported by the Railroad Commission every month. So where we see the divergence between the estimated inventory from Genscape and the estimated inventory adjusted for the Railroad Commission inventory, the blue line, where those two things differ are places where the Railroad Commission inventory comes in at a value that is different than what we would have expected from our observations. There's a few things about this analysis which I want to take some time to explore and dig into a little bit. So in this next slide, we're looking at some of these events throughout all the history that we've covered. So at the very beginning, we start at the same value as the Railroad Commission has. As we roll through the month of May 2014 and into June, you see that there's a stair-step value where the inventory that's reported diverges from what we've been able to observe is happening at the facility. Coincidentally, in the posting from the Railroad Commission in July, we see that stair-step value come back down. And so then they're back in alignment with us at the beginning of July, and another step away in the beginning of August. We stay pretty close to each other the whole way up through November, and then we get another stair-step value in December and an additional one in January, and then a step back down in February, and a large step back down in March. The inventory then steps back up again in April and coincidentally aligns with our values, and then diverges a bit down and back up to align with our values again in July. This has brought a whole lot of different questions to mind for us at Genscape. One, of course, is the Texas Railroad inventory an accurate reported value or not? I think we have some concern as to whether that's true. Regardless, well, I guess I should say we've queried the EIA to try and find out if the individual facility data that they receive is the same as the data that the Railroad Commission has. Unfortunately, they've been unable to respond to our queries because all of this information, as we all know, is private. It's not available to be public information from the EIA, so they've been able to confirm or deny the accuracy of the Railroad Commission data. This has made our estimating inventories at individual facilities a bit of a challenge. As we look at the North Lansing data, you can see here that we have some similar challenges on the individual facility for North Lansing as well. Although one thing that is good about that North Lansing data is over the entire accumulated time volume of data that we had, our total error over a year is still less than 4 BCF in what we observe, or our divergence from the Railroad Commission data is less than 4 BCF over that entire timeline. So even with the stair-step values, the methodologies that we're applying are observations that do have value and are meaningful in the physical world. All of that said, because of the challenges we had at individual facilities, we've decided to step back out and take a different tack on all of this information. So we have focused on the producing region weekly storage information as filed by the EIA. With this information, we've taken a couple of different slices on it to look at what shows up weekly on these numbers versus what's available from the public information from all the pipelines. So this first view is a conventional field weekly estimates. On the left side, you can see the correlation between what we can observe in the public data as it's reported to the pipelines and how that relates to the EIA weekly inventory. So you can see that that's about a 0.84 R squared. On the right-hand side, you can see what happens when we add our proprietary observations into the public data to provide a more complete sample. So if you look at the producing region, especially in the conventional world, very little gas is available. Almost all of the intrastate pipelines or storage facilities in Texas are directly connected to almost all the conventional facilities are directly connected to intrastate storage. So that means that by adding in what we're able to observe for our Texas data, we are significantly improving the sample size. And in looking at that sample size improvement, we strongly improve the correlations for those samples, and that moves that correlation to an R squared of almost 93. In addition, that does reduce the error in our models as well. So looking at the salt domes, the public data is actually is a better sample for the salt domes. We do improve the sample size by adding in our proprietary monitored observations, and that does improve the skill of, or at least the correlation, as well as then the error in the models, even though the public data are pretty good for the salt samples. As we look at the entire market, you can see here in a second that the public data correlations broadly for the entire producing region are 0.95, with the public and proprietary data samples correlation improving to 0.97 with an error reduction of about a half BCF a week in the total skill of what we've been able to put together from a correlation perspective. So then we'll dig into a little bit to how the models improve, or how our proprietary observations can improve your storage estimates, some of the methods that Hannah's used to apply these observations to her models.
So in my models for each of these facility types, I used our observations as independent variables, building a multivariate regression in order to create these improvements in correlation and reduction in error. I didn't find that we needed to use the estimated values at North Lansing and Bimla, but that the models were perfectly happy with our observations and the daily injection and withdrawal activity indicators. So this is what we're currently providing. We have observations at North Lansing and Bimla, and with Clear Lake and Spindletop having injections only. Markham, Bowling, and Dayton North, again, also have complete coverage, observations daily, and daily estimates at North Lansing and Bamel. As we continue to build out this data set, we'll be adding observations as soon as they become available. So in the next 2 weeks, you should be seeing West Clear Lake gaining its withdrawal observations, and Spindletop shortly thereafter. And about 6 months after the start of observations, we should be seeing our daily estimates show up at each facility. We are currently delivering this data via our data feed and through a daily emailed report. In the next couple of weeks, we will have this available in the analyst as well.
Okay, so with that, I want to quickly note that if you have any questions, please go ahead and use the questions box. And also we have a poll that we'd like you to respond to. Basically, we want to find out in which state you would most like to gain additional insight into intrastate storage. You should be able to see the options there: Louisiana, Michigan, Illinois, Ohio, or others. So if you could please go ahead and make a selection and submit those. We'll give it just a couple seconds here for folks to get their responses in, and we'll see what the consensus is. All right, so based on the poll question, those on the call have said, wait for it. All right. So we've had, this is important to note here because we've actually had very good attendance on the call today. So looks like Louisiana followed by Michigan are the areas that are most of interest. And the reason we ask this question is because we take client feedback and market feedback very seriously. This is the kind of information that we can then take and apply. So there's a pretty good chance that we might begin investing efforts in these markets.
And we'll definitely follow up with the other, because I'm curious which other regions people are interested in getting broader coverage for. So that'll be great.
And to John's point there, in terms of what we are interested in, we did receive a couple of questions. So one of the questions, John or Hannah, says basically, what is the timeliness of your information data gathering? And what is the timeliness of how you report the data to clients or subscribers?
Our megawatt estimates and infrared images come in real time. As we have analysts looking at the infrared images and determining the event states and whatnot, that's on a bit of a delay right now. We're working to get that daily. And our reporting of all these come out on a 2-day lag at this point. Going forward, we're going to have this out daily and timely.
I mean, put that in terms of the gas day, if you would.
So right now we're 2 days behind in the gas day in reporting. And we're 1 day behind in our analysis of the infrared images. Megawatts are real time.
Right. So again, we've got all this information coming in all throughout the day. We believe that the vast majority of people who are looking at this information will be looking at it from the perspective of using it for storage modeling. But if moving the published times into a more real-time availability is a critical factor, that is certainly something that we can do. It's just not something that we expected would be of immediate and urgent need.
Okay, and following up on that, I think Hannah touched on this earlier, but we did have a question as to how the data is made available to clients. How is it delivered?
Right now we're sending out a daily report that has the data, like I said, 2 days behind via email. Data comes out in the data feed as well. It's basically the same format. And in the next couple of weeks, we'll be putting this all in Analyst. That should be our most timely and up-to-date data set and way to ingest these data. With the data feed, yeah.
Okay, we got a bunch of questions. Again, we will do our very best to answer some of these following the call, but in the interest of time, we'll take one more. We had a question that came in with regards to history. How much history do you anticipate we will be able to make available, and how far back would that go?
The history for each of these facilities varies. The longest data sets we have are for North Lansing and Bamel. For Bamel, we have back to May of 2014. North Lansing, we have to November of 2014. And most of the later ones have been added this spring.
As far as the correlations go for this information, most of the results that you've seen so far from us are over the past 12 weeks. As a matter of fact, when we initially put together most of this presentation, it was only 10 weeks of data, and so we got 2 more weeks and saw some minor improvements even to our correlations there. So we expect these correlations will get a lot better as we get more history, but there's not a whole lot that we can do about making up history on things that we're physically observing. So it's really dependent upon, when we can get our cameras installed, when we can get the EMF monitors installed. But we are extremely excited about the fact that we're able to already, with the limited history that we have and the raw observations that we have in many of these facilities, use this information to make significant improvements in the analytic results of our models.
Okay, and again, as I noted, we've received a lot of questions. We will do our best to follow up with folks individually. Also want to remind you that the recording and the slides will be made available, so if there's something you missed or want to take a look at, that will be available. Also, just want to make one last note. Genscape is hosting an oil and natural gas symposium down in Houston on September 30th. If you register by this Friday using the promotional code Intrastate 2015, as you can see here on this slide, it'll take $100 off your registration fee. So we strongly encourage you to please go to our website, look at the agenda, and register early and come on down for the symposium in late September. So with that, we'll wrap it up. If you have any questions that you were not able to submit here, please feel free to submit it via the contacts shown on this last slide. Otherwise, thank you very much for your time today and for attending. We hope you found it useful, and we look forward to speaking with everyone individually. Thank you.